Okay guys, so for our first problem dito sa random problem set na sasagutan natin for the topic of string. Ayan. So basahin natin. The rigid bar A, B, ito, and CD, this one, are supported by pins at A. So may pin connection dito and D. The vertical rods are made of aluminum. So dito sa point na to, meron siyang aluminum rod. And dito sa member CD, ayan. So ang connection niya between point B and C is a bronze rod. So we need to determine the vertical displacement of the point where the force P of 10 kips is applied. So hanapin natin yung vertical displacement dito. Okay? So note, neglect the weights of the member. So di-disregard natin yung weight ng bawat member na yan. Alright, so first thing that we need to do is to make a free body diagram. Pero I will just take advantage of this figure. So ilagay na lang natin yung mga internal forces na makikita natin dyan. So kapag pinutol mo dito, again, kapag mga rod yan, so meron ka dito tensile force. Okay, so pangalanan natin to as our P aluminum. And then dito, pag pinutol mo siya, ayan. So meron siya ditong downward force. So let's name this as P bronze. And then kapag kinanek mo din siya sa kabila, do sa CD, ayan. So pataas naman siya dito to make it balance or in equilibrium. Okay, next. Since ito is a pin connection or hinge, so meron dyan mga reaction, but then again, hindi naman natin siya kakailanganin. Kasi, ang gagawin natin is magte-take tayo ng moment dito sa point A and point T para at least yung mga reactions dito is i-disregard natin. Pero sige, lagyan na rin natin ng direction yan. Let's assume this as AX and this one as AY. And then dito, sige, assume lang naman yan. DX and then DY. Again, di rin naman natin siya kakailanganin. Pero for the sake of this discussion, i-drawing na lang din natin. Okay, so nakabuo tayo dyan ng dalawang free body diagram. So ito, sa part ng bar AB, so pangalanan po natin siya as free body diagram 1. And then itong baba, yung bar CD, so siya is yung free body diagram number 2. Okay? Ayan, may free body diagram na tayo. Next thing that we need to do is to make an equation using the equilibrium equation. Okay? Pero, ang gawin na rin natin para at least dire-diretso na tayo. Mag-drawing tayo dito ng line. Palitan ko lang yung kulay ha. Ng blue din. Okay? So, do-draw ko dito ng line. Ayan. Tsaka ito. Okay, so again, sabi nga doon, yung mga deformation na mangyayari is mas maganda kung i-exage natin yung pagka-drawing niya. Para at least kitang-kita. Okay, so because of this load, alimutan ko pala islagay ito. P, kung saan binigay naman yung value ng P, which is 10 kips. Ang tendency niya, hihigitin niya pababa to. So, ang mangyayari dito sa mga bars mo, bababa siya. Tama? Or, ganito yung magiging itsura niya. So, yung initial position mo ng CD and yung AB is horizontally level. Pero because of this 10 kips load, ayan. So, in-exage ko lang yung drawing. So, bumaba yung rod. So, ito na yung magiging C. Panibagong C. So, sabihin natin siyang C prime. So, bumaba dyan. So, syempre, nahigit yung taas. So, anong nangyari dito? Bumaba rin sa part na to. So, ito, let's name this as our deformation or delta aluminum. Okay? Or yung symbol na bulate. Okay, next. At this point B, dito kasi ako medyo nalito ng konti. Kasi ito, dito sa point na to, kung mapapansin nyo, di ba, ang rod na yan, this is made of bronze. Pero hindi kasi natin siya pwedeng i-label na delta bronze. Kasi somehow, yung effect nung deflection or deformation na nangyari do sa aluminum will somehow affect the deformation dito sa bronze natin. Okay? So, ang gagawin ko na lang muna dito sa point na to, I will name this as my, sige, pangalan na natin as delta B. Okay? Or yung deformation dito sa point B na to. Okay? From which, i-relate natin yung delta B in terms of yung delta aluminum natin. Okay? So, paano natin ma-relate yung dalawa? Ayan. So, tama. So, considering our free body diagram number 1, sige, dito ko na lang isulat. So, considering FBD1, ayan. So, by ratio and proportion, guys, we could say that yung delta aluminum mo, so by ratio and proportion, kung mapansin nyo ano nabuo natin dito, di ba triangle? Ayan. So, ano to? Ito yung si delta aluminum. And then, itong delta B. So, that will be your distance here is 5. Okay, nakita? 2 plus 3, 5. And then, ito will be 2. So, dun yan lang nakuha yan yung ratio and proportion na gagawin natin. So, burahin ko lang ulit. Pinakita ko lang. So, deformation of aluminum or delta aluminum over 2 is equals to delta B all over 5. Or yung delta aluminum mo is just equals to 2 over 5 delta B. So, 2 over 5. Ayan. Okay? So, the next equation, again, considering the same free body diagram, kukuha tayo ng equation of equilibrium. Ano? So, again, ang gagawin natin, just take summation ng moment dito sa point A. Ayan. So, meron ka lang dalawang force na i-consider dyan. By taking summation ng moment, assuming counterclockwise is positive, take summation ng moment at point A. So, again, itong dalawang force lang naman to ang iikot niyan. So, yung P aluminum mo, multiply by the distance of 2. So, minus. So, ang gawin ko, transpose sa kabila, kaya naging equals yan, guys. Equals to P ng bronze, force, times the distance of 5 feet. So, in short, yung P aluminum mo is just equals to 5 over 2 or 2.5 of P ng bronze. Okay? So, next, ayan nga, since nakakuha na tayo ng relationship dito ng deformation ng aluminum and bronze, and at the same time, using the equilibrium equation, na i-relate natin yung P aluminum sa P ng bronze, we can now proceed dito sa member CD. So, ang pinapahanap talaga dyan, guys, is ito. Ano daw kasi naging vertical displacement do sa point kung saan naka-applied yung load P. So, let's just name this as our delta na lang siguro. Ano? And then, ito, again, yan is yung deformation at point B plus yung deformation mismo ni bronze. Again, sabi ko nga, wag malito. Because of this pulling force P, ayan, because of that load P, which is 10 kips, anong nangyari nga, nagkaroon dito ng P bronze. Ano? Kung saan yung P bronze na yan, since that is tensile force, di ba binatak niya? Anong nangyari dyan? Nag-elongate siya. So, ang mangyayari dito, that will be your delta bronze. And then ngayon, sabi ko nga, since dito sa part na to, nabatak rin kasi siya ng aluminum. Ano? So, ibig sabihin, nung hinigit ng aluminum, nagkaroon ng elongation, kaya na-form to. Ano? And then, because of this deformation na to, so, syempre, dito sa point na to, lalaylay pa yan. So, siguro nagka-idea na kung ano yung magiging total deformation pagdating dito sa point C na to, or do sa second free body diagram yan. So, that is delta bronze plus yung delta B, which yung delta B is in relation with dun sa delta of aluminum. Okay? Siguro nalilito pa, nahihirapan pang imagine, pero ulitin natin. Ano? Again, Because of this stand keeps load, nagkaroon kayo ng mga internal forces do sa rod. Ano? Again, since rod yan, that is always in tensile force. And tandaan nyo, kapag tensile, ano bang ginagawa ng tensile? Di ba hinihigit niya? And nung hinigit nila, humaba. Ngayon, una muna tayo dito. So because of this P aluminum, nagkaroon ng elongation or deformation aluminum. That is delta aluminum. So syempre, humaba yan. Anong mangyayari do sa rod mo? Syempre, bababa siya ng ganitong distance. And yung distance nga yun, or deformation na yun, that is your delta B. Magkaiba yan sa delta BR ha. Okay? So, ngayon, dumako naman tayo dito sa sa bronze mismo. Or dito sa member CD. So, because of this P bronze, syempre, hinigit niya ulit eh. So, nagkaroon ka ng deformation BR. But, again, isasama mo dyan or i-add mo yung deformation na nangyari doon sa free body diagram 1. Kasi madadagdag siya dito eh. Ayan connection kasi siya. Okay? So, kaya, ang nangyari, itong delta B na to is dinagdag natin sa deformation dito. Kasi lumaylay na siya dito eh. Saan ba pupunta yan? Diba? Matatransfer lang siya dito. Kaya nangyari, delta bronze plus delta of point B. Again, yung point B mo, the delta there, is in relation nga dito sa delta aluminum. Okay? So, anong sunod natin gagawin dito, guys? Ganun lang din. Kagaya ng ginawa natin dito kanina, i-relate lang natin siya considering the equilibrium equation and by using ratio and proportion. So, considering here, free body diagram number 2. So, dito tayo titingin, guys, dito sa free body diagram na to. So, unahin na lang din siguro natin yung by ratio and proportion. So, by R and P, or ratio and proportion, yung delta bronze plus delta B, again, yung delta B natin, ito is in terms of delta aluminum, no? So, siguro gawa natin to ng another variation. Okay? So, in terms of delta B, or that can be written as delta B. So, algebraic manipulation lang. Ito, itataas ko dito and then ibababa ko. So, that is 2.5 or 5/2, di ba? So, ito tataas. Then, ito bababa of delta aluminum. Okay? So, plus delta B yan, from which yung delta B mo nga is 2.5 of delta aluminum. Huwag malilito ha. Hindi ko na lang din sinusulat kasi limited lang yung space natin. Ito lang yan ha. Ratio and proportion. Itong triangle na to. Over, ano yung distance na yan? 4, di ba? So, ginawa ko lang siya in terms of delta aluminum. Kasi ano lang naman yan eh. Ayun yung original material natin. Aluminum and yung bronze. Is equals to yung delta, itong triangle na yan, over distance of 2. Or delta can be computed as kalahati lang, no? So, tataas to, divide. Or that is delta of bronze plus 2.5 of delta aluminum over 2. Kasi 2/4. Sinimplify na lang natin. Okay, so siguro lagyan natin ng mga label to. We'll let this as our equation number 1. This one as our equation number 2. This one as our equation number 3. And last, yung equation 4 natin is manggagaling nga doon sa pagmo-moment dito sa pin at point D. So, by taking summation ng moment, kita pa ba sa OBS to? Ayan, kita pa naman. Is equals to 0. So, our equation will be P of bronze multiply by the distance of 4. Ayan, nasa figure naman. And then, minus, so transpose sa kabila, equals positive 10 times 2. Or in short, yung P ng bronze mo is equals lang sa 20/4. So, that is equals to saan? 5 times 4, 20. So, 5 keeps. And, so may isa na tayong value ng force. Again, from the previous equation, ayan, yung from equation number 2, substitute lang natin yung 5 here. So, we will have the value for P aluminum, which is equals to 2.5 times 5 So, press lang natin sa ALQ. So, 2.5 times 5. So, that is equals to 12.5. 12.5 keeps. Okay? Ayan. So, since may mga value na tayo niyan, pwede na nating computein yung value mismo ng mga delta nila or yung deformation. Okay? So, again, yung deformation is a general formula of PL all over AE or yung PLAE. Okay, so I think let's start first with the aluminum. So for the aluminum, so that is equals lang sa 12.5, so that is in kips. Ano ba yan sa ilalim? So ito, kips, so that's why I will convert it to PSI. So i-multiply ko siya ng 1,000. Ano? Kasi 1 kips is to 1,000 PSI. PL, so ano yung length ng aluminum rod natin? So that is 3 feet. So to make the units satisfy each other, i-convert natin yung 3 feet to inches. So paano nga mai-convert yan? So just multiply it by 12. Okay? So wag na magtaa kung saan nanggaling yung 12. Kinonvert lang natin. Divided by 0.75. And then times 10 times 10 raised to 6. Okay, so we will have the deformation for the aluminum or delta aluminum of 12.5. So guys, pindot kayo. Times 1,000 times 3 times 12 divided by 0.75 and then divided by 10 times 10 raised to 6. So our answer for that is 0.06 inches. Okay? Next, this time, para naman do sa bronze. So for the bronze, same thing. Nandiyan naman yung mga material properties natin. So yung force na ginamit so that or na-solve natin is 5. Again, multiply it by 1,000 to make it in pounds. Times the length. So that is 4. Again, convert it to inches. So times 12. Divided by the area, which is 0.25. And then the modulus of elasticity. So that is 12 times 10 the 6. So we will have... Oh, but aluminum. So delta of bronze. Ayan. So pindutin lang natin guys. 5 times 1,000 times 4 and then times 12 divided by 0.25 and then divided by 12 times 10 to the 6. So our answer is 0.08 inches. Okay, so since meron tayong mga value nito, again, using equation number 3, masosolve na natin guys yung delta mismo or yung vertical displacement at point do sa load na merong 10 kips. So using equation number 3, again, nakagawa na tayo ng equation for delta. So substitute lang natin itong mga value na to. So delta bronze, 0.08. And then plus 2.5 of delta aluminum, which is 0.06. 0.06 and then divided by 2. So what is delta? So 0.08 and then plus 2.5 times 0.06 and then divided by 2. So the answer for that is 0.115 inches. Okay? So, box lang natin. Ayan. So, sobrang liit na niyan, ano? 0.00115. 0.115 inches. Ayan. So, guys, again, I'll give you 3 minutes to copy the solution. So, you may start copying. So, 1 minute pa. So, dito lang naman sa point na to, medyo naakalito yan. Ano? Eto, kung paano naging ganyan yung equation. Basta again, sabi ko nga, yung deformation or yung displacement na nangyari dito sa point A. So, kung bababa to, dapat bababa rin siya. Okay? So, yun yung delta B. And then, since meron dito ang tensile force, so, that will cause also displacement na delta bronze. So, to get the total deformation or the displacement happen at point B. So, that is just the sum of delta bronze plus delta B. Which is yung delta B nga is yung relation ng delta aluminum. Okay? So, mas ano to, ito medyo okay pa. Yung temperature kasi, may ganito rin mga problems kasi sa thermal strain. So, yun yung mahirap. Trial and error siya. Yung temperature, hindi mo kasi alam kung alin yung mas mag-exceed yung temperature or yung sa tensile or axial force. Okay? So, may times na magne-negative. Yun ang problema. Pero pag positive, ayan, okay yan. Okay, so, guys, let's proceed with the next problem.